Starting. There we go. Live stream is starting soon. Let's see if it's actually working. And why is YouTube still on starting soon? That is not what I want. There we go. Okay, now I can see it's working. So hello everyone to the February Patreon Hangout. If you're here live, you are in the $5 per month Patreon tier. So thank you for that. And yeah, as usual, if you've got questions, the best place to ask them is in the live chat, right? Wait, is this is not mirrored for you? So over there, right next to the video, we've got the live chat. If you've got stuff coming up right now, or if you want to ask stuff that you didn't ask beforehand under the Q&A announcement post, feel free. You've got caps lock on. Feel free to ask them here in chat. So yeah, right now, half an hour hangout for Patreon only, and in an hour, so 6 p.m. here, we're going to be doing a live on-shape design experiment sort of thing. That's going to be, that sounds like, to me, it sounds like it's going to be something that can go horribly wrong or it can go really well. So we'll just have to see for now. Let's just jump right in. So this is with the Hangouts app, which means that I'm not going to be able to use OBS Studio, but should be good nonetheless. So let's start with the questions on this one here. And Paul Clark asked, he upgraded his machine to 0.9 degree stepper motors. Yeah, Murphy's Law, it will go wrong probably. The 0.9 degree stepper motors for X and Y, and now his board is resetting, or bed is overheating, or nozzle is overheating. So his question is, what's up with that, and why is that going on? And I think on this one, on the patrons only accessible to anyone post, someone asked about 0.9 degree motors as well. They were this one. First time with this, but very noisy. So his 1.8 degree motor is much quieter than the 0.9 one. So let's actually start out with Paul Clark's here. Horrible out of focus. It might just be that this webcam is crap. It's a Logitech C170. These are not great cameras, but well, I might, for the stream later on, I might have to bring up the big guns and actually use one of my Panasonic. So let's start out with the 0.9 degree board resetting question. So the thing is, if you've ever tried, yes, it is a processing power limit as far as I know. So if you've ever tried the DRV 8825 drivers, which do up to 32 times microstepping, if you've tried those on a Marlin-based 8-bit board, you will have noticed that there is, oh, the screen grab was unreadable. Okay. You will have noticed that the maximum speed is actually really limited because of those that high amount of pulses that the board will have to send out to power those 32 times microstepping. So it's already, most boards are already at the limit with 16 times, and if you add 32 times microstepping, that's just going to be too much for them. And going from 1.8 to 0.9 degree motors is pretty much the same thing, just on a hardware side. So you actually gain real resolution, but still have to pump out twice as many, twice as many step pulses. So my suggestion for that would be, if you're going from 1.8 to 0.9, yes, that is a real upgrade. I just bumped the microphone, I'm sorry. That is a very real upgrade, and it will increase your 3D printer's resolution, but it's also going to double the processing requirements on your board, and the 8-bit boards are already at their limit. So what I would suggest is just step it down to 8 times microstepping, because you don't need that 16 times microstepping. There is, in fact, if you look at prints from an 8 times microstepping to a 16 times microstepping setup, the differences are marginal. They're like barely visible at all. And with the 0.9 degree one, you don't need the 16 times microstepping. So step that down to 8 times. You should have the same processing requirements as with the 1.8 degree motor in 16 times, but you're still going to be better off. And that should sort out the issues with the processor running out of processing power. Actually, if we zoom in here, it might be much more readable. There we go. So yeah, the bed was overheating, nozzle was overheating, board resetting. That sounds like the entire thing is just out of processing power. So the other question for 1 or 0.9 degree motors was, there we go, Christian. I don't know if that is a German name or the Bergi, the bird. He switched to 0.9 degree motors on a smoothie setup. Yeah. On a smoothie setup, and the 0.9 degree ones are just much noisier than the 1.8 ones. So the thing is, smoothie uses, or at least the smoothie boards that the regular ones use, the Allegro A4988 drivers, and those work much better with high current, low inductance motors. So if you've got a motor that is rated for 2 amps and has a very low inductance and resistance to make that work, the Allegro drivers are going to work really well with that. However, if you have a motor that has a high inductance, a low current, and a higher voltage, which would be something you'd be running for 24 volts, the Allegro drivers are going to have some issues with that. And that's, for example, something we saw with the Atom 3D 2.0 conversion to the smoothie board. That is like the very extreme case that printer uses those long, high inductance, low current motors that in theory have a whole bunch of torque, but do require a higher voltage to run them properly. And they work much better with the TI DRV8825 drivers than they do with the Allegro drivers. So that's just something that comes down to, so the issues he's having, that is just something that comes down to, matching drivers to your motors, or vice versa, matching the motors to whatever drivers you have. I know there is much less of a selection with 0.9 degree ones, but you still have a choice of going with a high inductance, low current, or a low inductance, high current one, depending on which driver you're using. Tridynamics actually do pretty well with either one, but do profit from that extra voltage if you have any to spare. So I hope that answers that. But again, looking at what he's writing here, he's doing smoothie, 32-bit microstepping, 0.9 degree motor. I'd actually recommend just stepping it down to like 8 times microstepping or 16 times microstepping. I mean, smoothie is not going to care, but it's not going to hurt either. And it just frees up a bit of processing power for other tasks. Okay, so the other one here was, nozzle height on SmoothieWare. SmoothieWare is actually a bit tricky with adjusting the first layer height. So essentially the nozzle offset. There is a wiki page on the Smoothie Wiki. The Smoothie Wiki is really well stocked, so there's a lot of info in there. So you will need to dig through that a bit, but there is a page explaining the entire setup process for Z offset, extruder Z offset, so hot and Z offset in doing that. And you don't have to edit the config. You can actually do that right through the command line just by sending G codes. So go to the Smoothie Wiki, figure that out. There is the right info there. So let's just burn through these by the first ones asked. So oldest first. What is my favorite 3D design software and why? So my favorite 3D design software is SolidWorks. Because it does everything. It does everything like really well. There are a few bugs in there, but it's so nice. It's a nice professional package. It does everything. It works great. But the problem is SolidWorks is extremely expensive. Unless you're a student, you can get student versions which are stripped down, or you can like buy the full version for a few $100 for like a 1 or 2 year license. But SolidWorks, really nice, but the problem is too expensive. So what I've been using lately is Onshape. Again, that's what we're going to be using in 50 minutes for just a collaborative project. And it does a lot of things that SolidWorks does. Plus, the best thing about Onshape, I think, is just the apps. So you can grab apps or plugins, more or less, whatever you want to call them, that just give you so much more functionality. You can get renderers, you can get parts libraries for like standard parts, screws, washers, bearings, that sort of stuff. You can grab FEA, so that's the German word. You know, and what's the English word for that? Whatever. So stress analysis programs, that's sort of the thing that you can all plug in. And the assemblies part, and Roman is saying he can figure out assemblies. The assemblies in Onshape actually work really well with those connectors. Maybe we'll get a chance to see that later today. So Onshape, that's sort of what I'm using. But of course, it's a very technical CAD program style. And there are other tools that fit different users better. So if you're doing like FEA, so yeah, it is. That's what it is. There are other tools that fit other users better. So try out a few different ones. They are, most of them are free, so you can pick whichever one you want, and whichever one works best for me might not be the one that works best for you. Yo, Chris Crudy is asking, what is the best way to auto level a delta? First of all, that's going to depend on what firmware you're running. It's different for any firmware you've got. It's different for Smoothie. It's different for the Duet firmware. It's different for Marlin. Essentially, that there are a few nice concepts with auto leveling, so essentially bed probing. I really like the one on the Automaker. It's just a smart way to do it. I do explain a bit about how it works in the review. Essentially, it's taking a nozzle, it's probing down onto the bed, and it's constantly measuring the distance from the tool head to the bed. And as soon as that stops changing, it actually registers, okay, this is the point where we touch down. It doesn't have an absolute distance measuring unit. It doesn't measure the absolute distance. It just measures when it stops changing. That works really well sensor-wise. Other than that, the sensors you can get, like the standard inductive ones, Beal Touch, the optical ones, or even a custom-made solution. The Atom 3D one is similar to what the Ultimaker uses. Any of those work hardware-wise. When it comes to software, it's just going to depend on what your firmware can do. Smoothie works really well for deltas. It does grid leveling, and that's just that makes bed setup really simple and really reliable and repeatable. Okay, next one. So Matthew Bird is asking, how does the Duet Wi-Fi compare to the Smoothie board? And out of the different manufacturers, which Smoothie board would I use? So first of all, there is only one Smoothie board. That is the Smoothie board. Arthur Wolf is actually quite unhappy with all these Smoothie using boards, and especially the MKS ones. For example, the one that the Tivo Little Monster uses, the MKS S-Base, because that they have sort of a bad relationship. Smoothie board and Smoothieware project putting on all the work for software, hardware, etc. And MKS is just taking the work and sending support requests towards the Smoothieware project, which freebooting, whatever. There is only one Smoothie board. The other ones, like the MKS S-Base, they are obviously their own type of board. They are also using Smoothieware. So I don't know, that's just going to be one of those decisions. Do you want to support the Smoothie project? Do you just want a cheap board? It comes down to that, more or less. It's also like feature-wise, the Smoothie board, the current one doesn't have replaceable stepper drivers. I think that's going to be one of the big differentiating factors between this Smoothie board and another Smoothieware compatible board. So it just comes down to what you're going to need, and the differences between the Duet Wi-Fi and the Smoothie board. I think the Duet Wi-Fi is more powerful than the smoothie board, but I've not really used it that much yet. So when I've tested out the Do It Wi-Fi, I will have a sort of a definitive answer towards that. By the way, guys, if for you 17 people watching, if you've got any questions you want to ask live in chat, I'm going to prioritize those over. Yeah, I'm going to prioritize those questions in chat over what we've got on the thread over on Patreon. So again, if you've got any questions, ask away. There is a reason why you are here in live chat. It's an option to ask stuff live. So for now, let's just move on with the ones here on Patreon. Christopher Day is asking, alternative hot ends extruders on the original Prusa i3 Mark II. What needs to be done to get one to work? How difficult of a task would it be? How about the Tornado series? How about Prometheus? Yada, yada, yada. So, I mean, the great thing about the Prusa i3 Mark II or any open source printer is it's, you can do whatever you want with them. The firmware is open. You can go and configure steps per millimeter, extruder direction. If you want to put a different hot end in there, you can, pick a different thermistor or thermocouple or whatever else you want to do. It's really, if you like know the firmware basics, which I've made a video about, it's not that hard swapping out an extruder software-wise. The largest job is going to be hardware. And just yesterday, I took off one of the Mark II extruders just to see how well that will fit on a totally different machine. So, okay. So, yeah, I mean, the mount is there. It's just three screws. They reach through the X carriage into the extruder, and one of them reaches into the motor. So I don't know. You can totally screw anything on there if you make an adapter plate, and that's gonna be that. It's really simple for the most part. Good support in the forums is excellent. Yes, community support. That's usually a big deciding factor for those kind of things. Yeah. So the question from Christopher Kerger. I think that was asked in the Patreon thread as well, somewhere, if I can find it, about which is the best slicer for dual extrusion. Yeah, so obviously, like the big three slices, Slick 3R, Cura, and Simplify 3D, they all do dual extrusion, and they all work well for a different sort of application for dual extrusion. I've not done that much with dual extrusion yet. I am working on that Mendel 90 rework that just, is going to do everything, hopefully, at some point. And yeah, so far I've worked with Cura on the Ultimaker 3, and I've played around with Slick 3R and Simplify 3D for dual extrusion stuff. They all work well. They all do the basic tasks, but some of them are better at a few different areas of that dual extrusion process. So again, that just comes down to preference. I personally really like the new Cura. The Cura 2 is like, it's just so good. But yeah, whichever one you like, if you have Simplify 3D, a lot of people are swearing by it. I've not really caught on to it yet. But yeah, whichever one you like. Fist-sized concave warp towards the middle of the bed, wreaking havoc on my first layer. Ooh. So Stefan K is asking, his Prusa Mark II has developed a fist-sized concave warp towards the middle of the bed, wreaking havoc on his first layer. So a fist-sized concave, so that would be a dent, essentially, in the middle of his bed. Well, first of all, I'd reach out to Prusa because I'm pretty sure that's not supposed to happen. I've had my Prusas running for hundreds of hours, and their bed is still really flat. I don't know how a concave dent would form there. I see how it would bubble up, like if the PCB actually splits, it essentially boiling up, or the PEI tape lifting up. But a concave one, get in touch with Prusa. I'm sure they're going to be able to figure that out. Right. Have I tried any printer with ball screws instead of belts? So just today, someone asked on I think on the Mental Max conversion video, someone asked, hey, how difficult do you think it would be to convert a CNC router to a 3D printer? And the main limiting factor there was how fast it could move. So the router he was talking about was able to move 1,000 millimeters per minute, which is 16 millimeters a second, which is about one fourth of the speed you'd typically be printing at. So that's just, that's just a factor that plays in there. So as far as that goes, yeah, as long as you can get up to speed, a ball screw is going to be super stiff. There's not going to be any ringing. There's not going to be any artifacts from resolution, because they typically gear down your rotation quite a bit. And ball screws can work well for a 3D printer if you can get them to move fast enough. So you will need to use a high pitch one, most likely, but other than that, it's going to work. It's going to work. I mean, for Z-axis, have I used one that uses a ball screw? I don't think I have, actually. For Z-axis, of course, a ball screw will work, but it's not going to be any advantage over just a regular lead screw, because you're not worried about backlash when you've got the Z-axis already like having gravity on your bed and on that spindle. So that's not going to be an issue. So some more questions on, hold on, let me figure out my windows here. Oh, now audio is working great. Full screen to this one. Okay. Which one was I going to talk about? There. Dual extruder systems, one hot end. Am I maybe building that dual extruder system on your old Mendel 90 project? Yes. I know that's confusing. Let's switch back to webcam. So the idea with that Mendel 90 conversion, which I am going to post a few pictures about on, hold on, can I actually, I should actually be able to show you some stuff. The Mendel 90 conversion that I'm doing is going to be exactly that. It is going to be a platform to try everything. Sweet, I can actually show you. Cool. That's going to be a platform just to be super modular. There we go. So still got the bed to work on, but that's like the X carriage back there. Can we get a better view? Maybe not. I'm wondering where those photos went. But yeah, that's the idea. It's going to be a platform just to throw everything on there, no matter what it is, whether it's a Prometheus system or a Prusa quad or just an E3D Kraken Volcano. That's going to be home to that, and I will be testing stuff on that machine. So yeah, once it's built, when it's built, I'm going to be testing the Do-It Wi-Fi and the Replicape, the current version of the Replicape on that. That's what I'm building it for right now. And once that's done, I can start experimenting with other things. Okay, that's from chat for now. Let's jump back to Patreon. There we go. Next to leading edge of a 90-degree bend. Ah, yes. Okay, full screen share. So Paul Clark is asking, did we have him before? I think we did, yeah. Paul Clark is asking, no matter what he adjusts, he just can't seem to get rid of vertical ripples directly next to the leading edge of a 90-degree bend. Try taking XY jerk down to 1, but the problem persists. So that is the classic overshoot issue. So when you have like a moving object, a heavy moving object, that moves and it should come to a stop. That's going to be, constant speed. I'm swiping the microphone. Constant speed is not going to be an issue. But as soon as it accelerates or decelerates or has to stop, there are going to be some forces on there. This is a fairly heavy aluminum microphone. So as soon as that's going to have to stop, there are forces on the entire kinematic system. That includes belts, that includes the stepper motors, which also have a bit of an elasticity to them. I guess that's how we can describe it. From one step towards the next half step position, either way, that is slightly flexible. If you try to turn that shaft on a stepper motor by hand that's powered up, you are going to feel that elasticity. And yeah, also like the belt and the belt teeth themselves also are elastic. So you just have to keep in mind when that's stopping and slowing down, you will get some resonance unless you're using something like the new Printabot does, or I think some of the 32-bit boards are using it as well, which is sinusoidal acceleration and deceleration, which is a really smart acceleration profile where it doesn't, like, if you look at the speed curves of a linear move, so that's mirrored for you guys, the speed's going to ramp up continuously and then stay at a constant and then ramp down. So that is, forces. If you look at the forces in the drive system, forces go up, then they're at zero while the speed is constant, and then the same amount down and then plop back to zero. And that jerk, essentially, that's what causes those ripples, because it gets the entire motion system resonating. And yeah, unless you can do sinusoidal, I'm going out on a curve here. Unless you can do sinusoidal moves, which you probably can't with the hardware you have right now, you are going to have to work on limiting those forces, that speed at which it ramps up. That is essentially your acceleration setting. So either work on acceleration, tuning that down, which actually helps a lot more than the jerk setting. I've played around with jerk and acceleration a ton, and acceleration is always like the one factor that is much more important than jerk. And also, like, do the basic mechanical checks. Like, make sure your belt is tight, make sure all your mounts are tight, make sure like the X and Y ends are tight and stuff, and reduce weight where you can. So if you've got the option of going with a pancake motor instead of the longer 48 or 52 millimeter NEMA 17 motors on the extruder, do that. Reduce weight, make your bed lighter. That's all stuff that's going to make those edges, those resonances, or those edges where one axis just has to stop and the other one has to accelerate, it's going to make that a lot smoother. Right, Ulrich Petri is asking, do you have an opinion on the BL Touch, especially compared to other forms of auto level sensors? Yeah, I mean, the BL Touch is, I've just tested one on the, or used one or mounted one on the TiVo Little Monster. And it is it's a nice option because it is physical. It is a mechanical sensor. So it actually, my finger's too short. Okay. It actually, here we go. Extends a probe that then touches down onto the bed. That is a physical contact point. So it's not going to matter whether you're using a glass bed, an aluminum bed, a whatever bed, if you have any sort of surface on top of it, it's just always going to probe that exact surface. I'm a bit worried about just the adding a mechanical part right there at your hot end. If that fails, it's going to crash your nozzle. I don't know how robust and how reliable the BL Touch is overall, but the concept just really makes sense. And if it's a high quality product, then again, the concept really sounds great. And so far on the TiVo machine, it seems to be working pretty well. And I guess the last one for today. Where are my windows? So many browser windows and tabs and crap. Hold on. 1 second. I will need to figure this out for the stream later on. There we go. Okay. There. Python Ronin is asking, would Y-splitter dual material like the Prometheus system get more popular or not? So yeah, Y-splitter dual material systems are using some of the same, or do have some of the upsides and downsides from something like a Cyclops hot an E3D Cyclops, which just has the one heater block, two filament entries, and then the single nozzle feeding both materials. Just that the Cyclops can, in theory, make that toothpaste like what's called the extrusion look thing when it actually uses both filaments at the same time, while a dual in one out system like the Prometheus system or the Pusha's dual or quad extruder systems can't do that. It's got some of the same downsides, like really dissimilar materials don't work really well. So if you're printing PVA and ABS, you're probably not going to work that great in something like a Prusa system, though I still have to try that out. I still have to experiment with that. It's also going to have to purge a lot between swaps. So one filament comes out, the other one comes in. It's going to have to purge the entire hot end to get that clean filament. That's going to be a lot of material if you have to swap on each layer. That's pretty much it. That's the two downsides. The upside is you don't get any ooze and you don't have any offset calibration to do for either nozzle. We're gonna have to see. I think something like what the Ultimaker does is with the retracting hot end might be better because you don't have to purge that insane amount that you have to do with a dual in hot end. Maybe it's going to be something like the Diamond hot end, someone asked about that, or the E3D Cyclops, which both I have not used, but I have a Cyclops. I still have to put that to use. Again, Mendel 90, that's where it's going to go. We'll have to see which solution people really want. In my case, my application for dual extrusion has always been and is always going to be PVA, because it's just going to be, it just makes things so much easier to print. It just makes the entire process so much more streamlined. So that's what I'm going for, and I don't think the 2-in systems or 4-in systems work that well for that. So for what I'm going for, I don't think it's the best solution. However, it might be something that manufacturers decide to put on their machines, and yeah, and just because I that's an interesting question. Okay, SCARA printers. Let's see. So let's actually pull that up for visualization. So that's going to be the last one for today. The SCARA robot. Why do we never see any of those? I guess it falls into the same. Yeah, so it's essentially, you can sort of see the kinematics there more or less. Yeah, it essentially falls into the category of stacked rotational axes. And like the big problem I've got with those, which is like the same issue that polar robots have, that have just the one rotating table and then a second axis with that. It's, they are really specialized. They have a bunch of downsides, like, those extreme positions that Delta printers even suffer from, where, you need an insane speed at your motor, or, just can't go there without, literally over cranking some of the joints. And, it doesn't offer any advantages over just a regular Cartesian design. Yes, you might be able to build it a bit more elegantly with like different components and stuff. But I mean, even these long arms here, they pose a real stiffness issue. So again, it's a nice design. It's novel. It's sort of like the design that Deltas would be if, Deltas wouldn't be able to print taller and stuff. I don't know. Again, it really doesn't offer any advantages over the typical Cartesian machine. If you build a Cartesian printer well, it's going to print insanely well, and it's not going to show any of the artifacts of a Delta or a SCARA or a Polar printer. And why would you have to do anything else if you've got a concept that works and is mechanically simple and just works for the job you want to achieve. So yeah, right. That's going to be it for today. I'm going to go ahead and prepare for the Onshape live stream later on. I still have to figure out a few techie things here because I'm doing this from the office up here, and I will need to try and get this machine to do video and audio and stuff well through OBS, and that still looks like it's not working too well yet, but hopefully we'll figure it out. Anyways, that's going to be it for today. Again, thank you for the support on Patreon. That really does make a difference. Much more of a difference than you might think. Just having that continuous income and not having to rely on sponsors or ad revenue or that sort of stuff really lets me work in a different way. And this doesn't have me worrying about those troll posts like Angus from Maker's Muse just posted that on his Twitter. How much did you get paid by Prusa to show that machine in every one of your videos? It's like, no, Angus has a great Patreon campaign as well. Neither he nor me nor Joe or any of the other YouTubers have to rely on like shady sponsorship like that. So again, that's what Patreon makes possible. Thank you for that, and maybe I'll see you later today or next month or on any of the posts. So thanks for being here and have a great day.